All right. So the first one says, an experiment consists of each of the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 being written on separate sheets of paper and placed into a hat. One paper selected at random. Determine the probability the number is even or greater than 4. So it didn't give us anything. So we have a total of 10 digits that it could be out of. It didn't give us anything. We're looking for the probability the number is even. So I'm going to circle all the even numbers. Or greater than 4. So I'm also going to circle all the numbers greater than 4. And I'll count up how many that is. 1, 2, 3, 4, 5, 6, 7, 8. So this happened 8 times out of 10. Which can reduce fraction or decimal place there. Questions on that?
Anybody an add?
Yeah. Okay, part B says, what is the probability the number is odd given? That's huge. Whenever you are given something, it changes your denominator. It's no longer out of 10. It's going to be out of what we're given. So we're given that the number is less than 6. So I'm going to come in here and find where the number is less than 6. Right there. So it's out of 1, 2, 3, 4, 5, 6. Out of those 6, that's my denominator. Out of those 6, what's the probability the number is odd? It happens 1, 2, 3 times out of 6, which is 1/2 or 0.5. Okay, number 2. How many 5-letter code words, so I'm going to do 1, 2, 3, 4, 5, can be made from the first 10 letters of the alphabet? So I'm going to write A, B, C, D, E, F, G, H, I, J. If the middle letter must be B, F, or G, the last letter must be a vowel, and no letter can be repeated. No letter can be repeated. So I'm going to start with my biggest restriction. My biggest restriction is the space that has the least choices, which is kind of a tie. So I'll just go with a vowel. I have A, E, or I. I have a choice of 3 different vowels to go there. But only one will actually go there. So since we can't repeat, I'm going to just pretend we use that one. And so these are the 9 letters we have left. My next restriction would be this middle one has to be B, F, or G. So I have a choice of 3 different letters to go there. I only used one of them though, so I'm just going to pretend I used that one. So I have 8 letters left. Any of the 8 could go there. Then I use one. Then I have 7. Then I use one. And then I have 6. And if you multiply these together, you get 3,024. Problem number 3. The probability that a new pizza restaurant will succeed at a given location is 0.75. So if that's the probability it succeeds, what's the probability against it succeeding? 0.25, because it adds up to 1. So the probability in favor that it will succeed is 0.75. The probability against is 0.25. It says determine the odds, which are always 2 reduced integers. The odds in favor. So the odds in favor are always going to be the probability in favor divided by the probability against. Probability in favor is 0.75. The probability against is 0.25. The quickest way to get that in reduced integer form is to use your calculator. So I'm going to go 0.75 divided by 0.25, enter, and I get 3. But I know my odds can't be just one number. So when it says 3, what does it really mean?
3 over 1.
3 over 1. So my odds would be 3 to 1. Number 4 says, if the day is sunny, 1,000 people will attend the baseball game. If the day is cloudy, only 500 will attend. Did y'all say 500?
Mm-hmm.
If it rains, only 100 people will attend. Local meteorologists say blah, blah, blah. So I'm going to make myself a little chart here. So if it's sunny, 1,000 people are going to go to the game. Meteorologist says the probability of a sunny day is 0.4. If it's cloudy, 500 people will attend. And it says the probability of it being cloudy is 0.5. And if it's rainy, 100 people will attend. So the probability of being rainy is 0.1. Determine the number of people that are expected to attend. So expected value, we could do it by hand by saying each x times its own probability and type that into our home screen. Or we could put these in L1 and these in L2 on our calculator and do 1 bar stat. And we're looking at the x bar. So just for grins and giggles, I'll do it both ways with you. So by hand, I would say 1,000 times 0.4 plus 500 times 0.5 plus 100 times 0.1. And then we would type that into our calculator. And we get 660 people. If I did it, though, using my calculator, L1, L2, I'd go to Stat, Edit. If I have stuff in there, I arrow up and hit clear and come down. Arrow up and hit clear and come down. My X values always go in list 1. My probabilities always go in list 2. I'll hit second quit. I'll go to stat, calculate. Choice number 1 is 1 bar stats. I've got the old school calculator, so I have to type in L1, comma, L2, enter. And the very top choice is X bar. So again, I get 660 people. Number 5, Will goes trick-or-treating to a house out of a huge bucket of candy. In the bucket, there's 25 Snickers, 27 Reese's, 20 Twizzlers, and 32 Laffy Taffies. He's allowed to reach into their bucket and pull out as many pieces of candy as possible. If he randomly pulled out 9 pieces of candy, what's the probability he got at least 1 Snickers? So if we think about what we would want to happen, if we want, out of these 9 pieces of candy, we want at least, and it's saying probability, that's a big key word there. We want at least 1 Snickers. That means we could have 1 Snickers, but that means we got 8 that were not Snickers. Or we could have 2 Snickers, but that means we got 7 that were not Snickers. Or we could have 3 Snickers, but that means we had 6 that are not Snickers. Or we could have got 4 Snickers, 5, 6, 7. That's too many. I'm going to work backwards. So the one thing, if he wants at least 1 Snickers, what's the one thing he didn't want to happen? No Snickers. So since it's a probability, I'm going to work backwards. 1 minus the probability of what we don't want to happen, which is 0 Snickers, and all 9 are not Snickers. So 1 minus, my denominator, in general, I need to know what am I doing here. I'm randomly pulling out 9 pieces of candy out of how many total pieces of candy? How many? 104? So out of 104 pieces of candy, I'm pulling out 9. Since there's 25 Snickers, I'll subtract that. And I get that there are 79 that are not Snickers. That's where I want all 9 pieces to come from. So out of the 79 that are not Snickers, I'm choosing all 9 of them. So I'm doing 1 minus the probability that they are all not Snickers. That means I'll at least get 1. Oops. So in my calculator, I'm going to do 1 minus 79, math, PRB, choose 9, divided by 104, math, year B. I get 0.9251. I don't know if it's a pretty fraction or not, math fraction.
Doesn't do it.
It's not good. All right, number 6. In the picture to the right, the outer and inner wheels are spun, assuming the wheels are independent and the outcomes are equally likely. That means spinning one wheel has no effect on the result of spinning the other wheel. Determine the probability that both wheels land on an even number. So the outside wheel has 1, 2, 3, 4, 5, 6, 7, 8 different possibilities. And we're looking for the probability it lands on an even number. So that's 1, 2, 3, 4 out of the 8 are even. And, so multiply, I want the inside wheel to land on an even number. So it has 1, 2, 3, 4, 5, 6, 7, 8 different outcomes. And 1, 2, 3, 4 even numbers. And so that's the outside wheel landing on an even number and the inside wheel landing on an even number. That comes out to be 0.4 or 0.25. And then part B says, determine the probability that the outer wheel lands on an odd number and the inner wheel lands on a number less than 6. So the outer wheel, again, we have 8 different possibilities. Odd numbers happen 4 times on the outer wheel. And, got to multiply, the inner wheel lands on a number less than 6. It still has a choice of 8 things to land on. A number less than 6 means it could be 5, 4, 3, 2, or 1. So there's 5 different choices for that one. So that gives us 20 out of 64, which is 5/16, or you could say 0.3125. Okay, number 7. In an ice chest, Patrice has 1 can of Sprite, 2 cans of Coke, 3 cans of Dr. Pepper, and 5 cans of root beer. I already wrote above it, that means 11 total cans. If Mark comes by and randomly selects 3 cans at the same time, so if he's selecting them at the exact same time, that means it's not one after the other after the other. That means it's a group of cans. So order doesn't matter, combination. And line 3. What is the probability all 3 cans are the same flavor drink? So if we look, we have 1 can of Sprite, we can't get 3 of that. We can't get 3 Cokes. We can get 3 Dr. Peppers, and we can get 3 root beers. And that would totally be that cool. So I can get 3 Dr. Peppers or 3 root beers. Those are my only choices. So my denominator, since it's a probability, is just in general, I'm choosing 3 cans out of the total number of cans. So out of the total 11 cans, I want 3. Specifically, I need 3 Dr. Peppers. So I'm going to get those out of the total number of Dr. Peppers, I want 3. Or I could get 3 root beers. So out of the total number of root beers, I want 3. So I'm going to put this in my calculator. You have to be careful putting this in your calculator. If you just type it all in at once with no parentheses, it's going to do order of operations for you that you don't like. So I would say do the numerator first. And hit enter, and then divided by, and then do the denominator. And we get either 1/15 or 0.0667. Part B. What is the probability he chooses at least 2 root beers? So he's only choosing 3 total. So that means he could get 2 root beers and 1 not root beer, because we need to get 3 total. Or he could choose 3 root beers. That's pretty fast. So I'm going to go forward. No need to work backwards on this problem. So my denominator, since it's a probability, my denominator is still going to be, out of the 11 total cans, I'm choosing 3. Specifically, out of the 5 root beers, I want 2. And out of the total number that are not root beers, how many are not root beers? 6. Out of the 6 that are not root beers, I want 1. Or, out of the 5 root beers, I want 3. And again, I'll do this with you. And so we have 5, choose 2, 6, choose 1, plus 5, choose 3. And I'm just going to hit enter, because if you hit divide by, it'll do order of operations that you don't want. Then divided by 11, choose 3. And I can math bracket if I want to. So I get 14 over 33, or in decimal I get 0.4242. Okay, number 8, it says, to the right of the results of a survey regarding the service at Lakeview Diner, what is the probability, so that tells me I'm dividing by something, the service for lunch was rated 4. So the service for lunch, that's right here, was rated 4. So that happens 15 times. It didn't give us anything. So that happens 15 times out of 200. We put that in our calculator. It'll either reduce it or we get this decimal right there. Okay, and then part B, it says, what's the probability a person had breakfast given? That changes everything. Instead of out of 200, it's going to be out of what we're given. We're given that the service was rated good. So there's 170 times the service was rated good. Out of those 170 times, the probability a person had breakfast happened 95 out of 170. That'd be 0.5588. Number 9 says 2 pairs 6-sided dice are rolled. Instantly look at your dice chart, which will be provided for you. One of the dice is blue and the other is red. So I made one blue and one red. It doesn't matter which you made which. What is the probability that the sum of the dice is odd, or at least one dice rolled a 3? It didn't give us anything, so it's out of 36. So out of 36, we're looking for the sum of the dice is odd, or at least one die rolled a 3. So the sum of the dice, I'm going to do at least one die rolled a 3 right there. The key to the or is not to add anything twice. So I've got all the places where a 3 is rolled. Now I need to also include every time the sum is odd. So that happens those 2, those 2, 4, those. And then I'm just going to count up all these blue ones here. So I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 23. Is that what y'all got? 23 out of 36, which is reduced. Okay. Then I'm going to erase that to do part B. It says, find the probability the sum is greater than 5 if it is known. That changes everything. It's not going to be out of 36. It's going to be out of what we know. We know the blue die rolled a number greater than 2. So if the blue die rolled a number greater than 2, that means it either rolled a 3, 4, 5, or 6. And so instead of out of 36, it's going to be out of these 24. Now we'll ask our question. Out of those 24, what's the probability the sum is greater than 5? So you can draw a line right here, and everything in this direction has a sum greater than 5. So if you add them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 times out of 24. can take a 3 out of both of those. So that probability would be 7/8. Okay, on number 10, it says 2 fair 6-sided dice are rolled. So I'm still looking at my dice chart. It says, what are the odds against? Keep in mind, odds are 2 reduced integers. 2 reduced integers. The odds against are always going to be the probability against divided by the probability in favor. What are the odds against one of the dice rolling a 6 and the sum of the dice being greater than 8? So I'm going to highlight where one of the dice rolls a 6. Then I'm going to circle out of those, it says, and the sum is greater than 8. So that could be 9, 10, 11, 12, 11, 10, 9. So that happens 1, 2, 3, 4, 5, 6, 7 times out of 36. So the probability in favor of this is 7 out of 36. The probability against it is 1 minus that. And if you need to do that on your calculator, you can. Say 1 minus 7 divided by 36 and put it back into a fraction, math frac, and you get 29 out of 36 is the probability against it. And so dividing by a fraction, same thing as multiplying by its reciprocal, so the 36's go away. So we get the odds against to be 29 to 7, which we could write like this, or we could write like this, or we could write 29 to 7. Number 11, it says, Mr. Hammond is in charge of selecting a committee of 9 from among 14 men and 10 women. In how many ways? So this is not asking for a probability. I'm not dividing by anything. In how many ways can this be done? Okay, so in how many ways, not looking for a probability, can this be done? At least 8 men need to be on the committee. So if we think about what we want at least 8 men, and we're choosing 9 total. So we could have 8 men and 1 woman, or we could have 9 men. That's pretty short. I'm going to work forward. If it is at least 1 man, that'd be 1, 2, 3, 4, 5, 6, 7, 9, then I'd work backwards. But this is short, so I'm going to work forward. And so I'm going to choose these 8 men out of the total number of men. I'm going to choose 8. And out of the total number of women, I'm going to choose 1. So that's 8 men, 1 woman. Or, out of the total number of men, I'm going to choose 9. And I'm not going to divide it by anything, because it's not a probability. It's how many ways can it happen. And so, typing it in, I'm going to have 14, choose 8, times 10, choose 1, plus 14, choose 9. Did I type that in right? You're right. Second enter, I left out a 4 here. There we go. 32,032. Okay, number 12. Hannah randomly chooses a sample of 6 balls from a bag containing 7 black, 2 blue, 6 green, and 4 yellow. In how many ways could exactly 5 balls of the same color be selected? And it said, in how many ways? It didn't say what's the probability. So I'm not dividing by anything. Probability is where you divide. So exactly 5 the same color. So looking through here, I could get 5 black. And if I do, that means I got 1 not black, because I need 6 total. I can't get 5 blue. I could get 5 green, and if I did, I got 1 but not green. Alright, and then we cannot get 5 yellow. So this is it. We can either get 5 black, 1 not black, or 5 green, 1 not green. So out of the total black ones, I'm going to choose 5, and out of the total that are not black, so I need to add up 2 plus 6 plus 4. So out of the 12 that are not black, choose 1. Or, out of the total green ones, choose 5. And out of the total that are not green, so I have 7 plus 2 plus 4, 13. I need 1. I'm not dividing by anything because it is not a probability. So I will type this in the calculator with you. So I'm going to do 7 math probability, choose 5, times 12 math probability, 1 plus 6 math probability, choose 5, times 13 math probability, choose 1. And I get 330. Number 13. Maddie collects elephant trinkets. She has 1 elephant plate, 3 different elephant pendants, 2 different elephant glasses, 4 different elephant pins, 2 different elephant statues. How many different ways could she line all these trinkets in a row? Is this going to be order matters or does it matter? Dashes or combinations? Dashes. She's putting them all in a row. So if you're setting something down in a row or lining them up in a row, that's going to be dashes. And it says she wants to keep the trinkets of the same type together. So we're going to do the elephant plate right there. There's only one way that can happen. And she has 3 elephant pendants. Any 3 could go on the left, then 2, then 1. And then she has 2 elephant glasses. Any 2 could go on the left, then 1. And then she has 4 elephant pins. Any 4 could go on the left, then 3, then 2, then 1. And then she has 2 elephant statues. Any 2 could go on the left, then 1. But we assumed they went in this order with the plate on the left, then the pins, then the glass, then. So we have 5 different types of trinkets here. 5 different types of trinkets here. Any of the 5 could have gone on the left. Then that would leave 4 to go here, then 3 to go there, then 2, then 1. So I need to multiply it by the types of trinkets. Any of the 5 could have gone on the left, then 4, then 3, then 2, then 1. And so multiplying this together, I'd have 1 times 3 factorial, 2 factorial, 4 factorial, 2 factorial, 5 factorial. It said in how many ways, and so I'm not dividing by anything. So I'm going to type this in. But quick question. If it had said, instead of in how many ways, if it had said what's the probability, what's the only thing we'd do different? It's the exact same question. Instead of in how many ways could this happen, if it said what's the probability this happens?
Divide by the total.
Divide by the total. And the total is just how many different things are we putting in a row? 4, 5, 6, 7, 8, 9, 10, 11, 12. So we divide by 12 factorial. So there's 12 factorial ways to set 12 things in a row. So that would be what's different if this were a probability. I'm going to type this in my calculator. 3 math PRB factorial. And I get 69,120 ways that could happen. Number 14, a raffle ticket costs $3. There are a total of 5,000 raffle tickets sold. they're giving away one first prize of $1,000. So I'm going to go ahead and start making a little chart here. So if I get first prize of $1,000, but I paid $3 for the ticket, that means I'm actually going to go home with $997. They're giving away 1 out of 5,000 of those. Then they're giving away 4 second prizes of $250. So the probability you win second prize is 4 out of 5,000. And the second prize is $250, but I paid $3 to play, so that would be $247 I'd go home with. And then they're giving away 10 third prizes, so the probability is going to be 10 out of 5,000. Third prize is of $50, but I paid $3 to play, so I'd go home with $47. The only thing left that could happen is I could lose $3. So if I add up how many people win, 10 plus 4 plus 1, 15 out of 5,000 win. So 5,000 minus 15 means 4,985 out of 5,000 are going to lose. So it says determine the expected net win or loss, and what would a fair price be for this one. So I'm going to put this in my calculator. I'm going to put my X values in list 1 and my probabilities in list 2. I'm going to go to my calculator. I'm going to go to Stat, Edit. I have stuff in there, so I'm going to arrow up and hit clear and come down. Arrow up and hit clear and come down. I'll type in my numbers. Probabilities will go in L2. Once I get everything in there, I'm going to hit second quit. I'm going to go to Stat, Calculate, 1 bar stats. I have the old school calculator, so I have to type in L1, comma, L2. New school would just make sure there's that L1, L2. Enter. At the very top, it shows X bar equals negative 2.5. That's my expected value. So you can expect to lose $2.50 on average for each ticket you buy. And then it also said to determine what a fair price for this ticket would be. Oops. And so to determine the fair price for the ticket, you look at how much did you pay to play and what's going to happen. You're going to lose $2.50. So you subtract the two. 3 minus 250. So what would a fair price be?
50 cents.
50 cents. So number 15, it says a code is to be created from the letters PATRICE and the digits 3, 4, 5, 6, 7, 8, 9. The code is formed by 3 letters, letter, 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 followed by 2 digits, followed by 2 more letters. It says the last letter must not be a vowel, so this cannot be a vowel. The first letter cannot be an A or an E. The first digit must be even. How many codes are possible? So it didn't say you can't repeat. That's a big one. If it doesn't say you can't repeat, then you can. Don't make up your own rule. So starting with my biggest restriction, it's going to be the last one, cannot be a vowel. So it could be P, T, R, or C. So I have a choice of 4 different letters to go in that last spot. I don't mark it off because I can repeat. The first one cannot be an A or an E. So it can be E-T-R-I-C. So I have a choice of 5 different letters to go there. I don't mark it off because I can repeat. So then I don't have any more restrictions on the letters. So I have 7 letters can go there, 7 can go there, and 7 can go there. For the digits, the first one needs to be even. So I have 1, 2, 3 different digits that can go in the first spot. I'm not going to cross anything off because I can repeat. So I have 1, 2, 3, 4, 5, 6, 7 different digits that can go in that spot. Fit it all in your calculator and multiply it out. You get 144,000. So number 16, it says the odds against. So whatever it says there, in this case it says against, are going to belong to the first number we come to. So I haven't even read the problem yet, but it says the odds against. So I know my first number is going to be against, and my next number is going to be in favor. I keep reading it now. The odds against Buttermilk winning the Triple Crown in horse racing are 82-3. Determine the probability that Buttermilk wins. So that's the probability in favor that Buttermilk wins. So that will be the odd in favor divided by both odds. The odd in favor in this case is 3. Both odds would be 82 plus 3. So we get 3 85ths, which probably reduces. No, it doesn't reduce, just kidding. But you could also write it as a decimal if you wanted. Number 17, a committee of 7 is to be formed from 10 parents, so there's 7 people. It's to be formed from 10 parents and 12 teachers. If the committee is to consist of 2 parents and 5 teachers, and that already adds up to 7, so I don't have to worry about any extras. How many different committees are possible? So it didn't say what's the probability, so I don't have to divide by anything. You only divide if it says probability. It just says how many. And so I want 2 parents and 5 teachers. And that's going to give me everybody I need. I'm going to get the 2 parents out of the total number of parents. And I'm going to get the 5 teachers out of the total number of teachers. I'm multiplying because it says and. I want 2 parents and 5 teachers. When I go to put this in my calculator, I'm going to have 10 math probability choose 2 times 12 math probability choose 5. I get 35,640. Okay, number 18. 3 crows, 4 blue jays, 5 starlings sit in random order on a section of a telephone wire. Find the probability that birds of a feather flock together. That is, that all birds of the same type are sitting together. So is this going to be order matters or order doesn't matter problem?
Order matters.
Order matters. We're going to do the dashes. Why? Because we're sitting set down in a row. And so, again, probability means I'm going to be dividing by something. So let's go ahead and figure out the denominator first. In general, just in general, no restrictions, what's taking place here? Birds are sitting on a wire. How many birds? 12. 12 birds are sitting on a wire. How many different ways could 12 birds sit in a row on a wire?
51,000.
How many birds could go on the left? So I'm going to do this. I have 12 different birds could sit on the left. Then 11, then 10, then 9, then 8, then 7, all the way down. So there's 12 factorial ways that 12 birds could sit in a row on a wire with no restrictions. Right? Now I'm going to get specific because it says, find the probability that birds of a feather flock together. That is, all birds of the same type are sitting together. So I'm going to put the 3 crows right here. Any 3 of them can sit on the left, then 2, then 1. Then I'm going to put the 4 blue jays right here. Any 4 can sit on the left, then 3, then 2, then 1. Then I'm going to put the 5 starlings right here. Any 5 can sit on the left, then 4, then 3, then 2, then 1. Did we assume anything?
Yes.
Yes. We assumed the crows were on the left, the jays were in the middle, and the starlings were on the right. So we need to take that into account. How many different types of birds could have sat on the left? 3. Then how many types could go in the middle?
2.
2. And that leaves 1 for over here. So I'm going to do 3 dashes to represent the order for the types of birds. Any of the 3 types could have sat on the far left. Then that leaves 2 types that could sit in the middle, and that leaves 1 type that could sit on the right. So I'm going to have 3 factorial for crows, 4 factorial for blue jays, 5 factorial for starlings, and 3 factorial for arranging the types of birds. So this is what I'm going to put in my calculator right here. Here we go. I'm going to go to type in my 3, math, probability, number 4. You don't have to hit the times sign, you can just type the next number. And divided by. And we get 2.16 times 10 to the negative 4, which is a really small number. And that's perfectly fine. You can write it just like that. What it's really saying is the decimal moved to the left 4 times. So it's 0.000216, if you're really wondering.